The following video is brought to you by Kaleidoscope. Beautiful patterns of life. In this video, we will be analyzing the concept of evolution through the lenses of critics. In doing so, we will be analyzing critically the experiment done by Miller and Urey. Here we begin by asking a question: can the origin of life be explained by natural processes? The origin of life is a mystery and has puzzled scientists of all ages. No scientist has yet been able to create a living cell from organic molecules. To solve the puzzle, scientists have proposed several hypotheses, such as spontaneous generation, abiogenesis, and of course biogenesis. The reference to these theories will be helpful in understanding the following content. Let us go over these theories one by one briefly.
There was a time when people believed that a living thing could arise from an inanimate object or a non-living thing. This was the founding principle of the theory of spontaneous generation. Spontaneous generation, however, refers to the theory that complex life arises spontaneously and continuously from non-living matter. Some evolutionists claim that complex life just spawns from non-living things spontaneously, without undergoing any premature development phases. Just like that. Abiogenesis is the idea, or the process, wherein the earliest life forms came about from non-living matter, such as organic compounds. These primitive life entities were not as elaborate as the living things we know today. They are less elaborate in form, structure, and function. Both spontaneous generation and abiogenesis share the common feature, wherein life could evolve from non-living matter. However, there are two aspects in which spontaneous generation differs from abiogenesis. In one aspect, while complex life could evolve spontaneously in spontaneous generation, it evolves from a simple life in step-by-step process over a period of millions of years in abiogenesis. In another aspect, while spontaneous generation depicts a process that involves a relatively shorter span of time, for example minutes, hours, or years, abiogenesis implicates millions of years to occur. Biogenesis refers to the idea or the process whereby a living thing comes from another living thing, particularly of the same type. Life originates either through sexual or asexual reproduction. A chicken from an egg is an example of sexual reproduction. While binary fission of amoeba into daughter amoebas is an example of asexual reproduction.
In 1924, Russian scientist Oprin and, in 1929, British scientist Haldane proposed, independently, a theoretical model for chemical evolution. Oprin and Haldane suggested life emerged from a series of step-by-step reactions between inorganic matter driven by large energy input. These reactions initially produced the building blocks of life, for example amino acids, then more and more complex molecules until primitive life forms arose. Let us hear what the evolutionists have to say about the evolution of life.
The evolutionists claim that the formation of life on the Earth is not because of an intelligent designer. On the contrary, it is a result of time, chance, and natural processes.
Does there exist any backup evidence for their claim?
Yes, it does. They put forward an experiment done by Miller and Urey.
But before we proceed with the Miller experiment, one handy piece of information will be useful for future discussion. The basic building blocks of all living systems are proteins. It is interesting to know that proteins consist of only 20 different types of amino acids. On average, how many amino acids are present in a biological protein?
Over 300 amino acids are present, arranged in a very specific pattern.
Let us now proceed to the Miller-Urey experiment. What was the main objective of this experiment by Miller?
To find out, how could the basic building structures of life have formed in the early period of the Earth? However, their intention was not to create life, but to demonstrate operant's model.
How did he carry out his experiment?
To implement his experiment, Miller needed two things. The first one was an environment similar to early Earth's atmosphere. And the second one was an input energy source to trigger the experiment. Miller used water, methane, ammonia, and hydrogen to simulate early Earth's atmosphere as the first input. The gases that have been chosen to simulate Earth's atmosphere do not interact with each other under natural conditions. Thus, Miller had to use electric sparks to trigger the interaction among the gases.
Now it's time to see what kind of experimental setup was put to use by Miller and Urey.
The illustration here shows a basic setup for the purpose of explaining the experiment. The setup can be divided into 4 chambers, namely, the input chamber, the evaporation chamber, the spark chamber, and the condensation chamber.
What was the outcome of the Miller experiment?
The output was the production of amino acids and byproducts.
Thus, evolutionists consider this as the first step in explaining how life could have originated. Could science go one step further and produce proteins from amino acids? Could that prove life can be created in the lab?
Hold on. Let us review the experiment critically.
Before we deal with the experiment critically, let us recall the claim made by evolutionists. The formation of life on the Earth is not because of an intelligent designer. On the contrary, it is a result of time. Chance. And natural processes. We have the following 3 arguments. How much of the experiment was left to chance? How far did Miller succeed in approximating the primitive Earth's atmosphere? Were Were the amino acids produced during the experiment the ones used in the creation of life? Let us find out. Let us consider the first point. How much of the experiment was left to chance?
In fact, the whole experiment was carried out in a controlled manner and nothing was left to chance. Miller had to separate amino acids from the mixture once they were formed. Had he not done that, the electric energy would have arranged them in another form. Remember the handy information: over 300 amino acids are present, arranged in a very specific pattern. He did this with the help of an intelligent design and did not leave it to chance.
How far did Miller succeed in approximating the primitive Earth's atmosphere?
He was far from being accurate, as he did not know how it was, and he had to resort to assumptions. He had made two assumptions about the Earth's primitive atmosphere. First, he assumed a careful selection of methane and ammonia gases to be present in primitive atmosphere. Second, he assumed that the primitive Earth's atmosphere was void of free oxygen, that is, a reducing atmosphere.
Why did he believe in a reducing atmosphere?
This is because biological bonds are destroyed in presence of oxygen. That means amino acid bonds are destroyed in presence of oxygen. If amino acid bonds are destroyed, then proteins will not be formed and, hence, it will not lead to the evolution of life. There is no scientific evidence that the primitive Earth's atmosphere was void of free oxygen. However, we do have strong evidence of the oldest rocks being formed in an oxygen atmosphere.
Let me bring up some of the observations made by Dr. Scott M. Hughes in regards to the experiment. 1. The concentrations of methane and ammonia were carefully selected to ensure the production of organic molecules. There is no evidence to suggest the Earth's atmosphere was so characterized. 2. There is no evidence to indicate the Earth's early atmosphere was reducing. There is, however, considerable evidence to suggest the Earth had an oxidizing atmosphere during most, if not all, of its history. 3. A methane-ammonia reducing atmosphere would be fatal to life forms. What does that mean?
Miller's approximation of primitive Earth's atmosphere would be fatal to life forms.
Let us now take the third point. Were the amino acids produced during the experiment the ones used in the creation of life?
The answer is no. According to chemistry experts, chemical reactions produce equal mixtures of left and right-handed molecules.
Thus, it is not just the environment assumptions that matters, but also the production of type of amino acids and the organization of them as well.
According to experts, out of over 20,000 types, only 20 types are used in life. Moreover, amino acids come in two basic shapes. They have two atoms, which are mirror images of each other. These are called left-handed and right-handed as per scientific norms. Although most amino acids can exist in both left and right-handed forms, life on Earth is made of left-handed amino acids almost exclusively. No one knows why this is the case.
All proteins extracted from higher-level organisms, animals, and plants, and from simple microorganisms like bacteria, molds, and viruses are found to be left-handed types. Let us pin down the time factor. As per the laws of probability, if the chance of an event happening is less than 1/10 to the power of 50, then that event will never occur. That is 10 to the power of minus 50 implies impossibility. Scientists calculated the probability of amino acids forming into a protein to be 4.9 x 10 to the power of minus 191. The probability of a small protein of 100 left-handed amino acids being assembled by random chance is an astounding improbability that there would not be enough time for that to happen. Thus, a protein is not even close to becoming a living cell, and the probability of getting a cell by natural process is 1 times 10 to the power of minus 40,000. So, what is the conclusion? Miller had actually produced a mixture of left and right-handed amino acids, and this is deleterious to life. Apart from amino acids, other molecules were formed like formaldehyde and cyanide, which are fatal to life. The probability calculations show that life cannot have had a random beginning. Thank you for watching. If you like this video, give us a thumbs up and share it with your friends. Do not forget to subscribe to our channel and hit the bell icon for more videos like this.